Hi everyone, am I audible? Yeah. So let me first introduce what we're going to speak about and then introduce the elite panelists who are all here, who've taken out time to talk about what's beyond EVs. So the first, I think as a finale session, this was very strategic for everyone to keep this is while we have discussed across from policy to what the government is doing to what all is the future of EV charging infrastructure in the country, globally, all of that have been discussed. Here, the panelists who are experts in their fields, and I'd love to discuss on what are we looking at beyond EVs. I mean, are there topics that we should be looking at which are equally important? And a couple of them, let me throw them to you. Right, first up is first and foremost is AI. Artificial intelligence, the data that we all are gathering, the data that's coming, do we have the kind of back-end infrastructure that can help us improve upon and bring a lot of those changes that we discussed throughout the day today a lot quicker? The second piece that we'll be discussing would be on the battery technologies. Can we move away from lithium ion? Can more smarter batteries come in? How are the next generation batteries are going to look like? And with the kind of panelists I have here, I can't just be talking batteries without actually talking about what happens to the batteries once they get degraded. What happens to the batteries once they get used up? How are we going to deal with that? Do we have a way around there? Some of the experts here are also going to help us understand a very interesting and important topic which may or may not have been discussed in the panels through the day is carbon credits. What's happening to the carbon credits? For all the operators and the clients and the customers who are really working hard and putting their heads together to get all the EVs on the road, what's happening to the carbon credit monetization and how's that working out? Finally, more on how AI can help us on the two-wheeler front, how AI can help us. I was able to see some videos of the Treel ad of how AI is going to help with the tires and the pressures and all that, but can we go beyond that? Also, a lot about the four-wheelers. It's a two-wheeler, three-wheeler, but while we are talking about beyond, I think we can. And that's where we'll also be looking at how are they becoming smarter. Giving you a quick introduction, we have with us Mr. Sunil, but he comes from the Murugappa Group, who's launched their four-wheelers and they're disrupting the trucking market pretty much. Then we have Mr. Tanveer, who's going to give us a lot of insights of we're going to talk about smart batteries or what's the future going to be there with batteries, but what happens when they degrade? What's happening to the second use, third use, or what's the thought process and where are things going there? Then we have Mr. Farhan, who's going to talk about how's the two-wheeler in all of this, how's the two-wheeler going to become smarter, how's the AI going to help the two-wheeler rider of all. Besides that, we have Mr. Nilesh, who's going to help us understand how's the charging infrastructure is going to look at in the next 2-3 years to come. And finally, we have Abhinav, who's going to touch upon, for me, a very interesting and very important topic for the entire industry. And when we are talking about decarbonization, are carbon credits. So let me start with Sunil ji. Mr. Sunil, is that you have an extremely deep insight on the battery and the battery technology. So, Mr. Sunil, tell me how are we going to go away from lithium ion? Is that the actual thinking globally that's happening to improve upon the supply chain? And where is the technology of solid state battery or sodium ion battery or hydrogen fuel? How mature are they? And what the time frames are we looking at? Please, sir.
Yeah, thank you. See, lithium is one of the best technology available because it is proven for many years. So it is being used for last 10 to 15 years in electric vehicles, and it is a very good use case. So whenever we do something in lab, the lab case is very different because you do in a small scale, and when you do something commercial, then the shape changes totally. So here the investments are very high, the raw material issues are there, where there are very few countries who have raw material. Raw material processing is another issue. So there are a lot of issues which are resolved and which are taken care of, and the technology has upgraded now. The biggest problem in lithium was energy density earlier. And in last 5 years, we are seeing continuous improvement in the energy density. And in some cases, it has reached now up till 500 watt hour per kg. So it is phenomenal because 3-4 years back, it was only 160 or 150, something like that. So these technologies are proven. So that is the reason why it is running today. Even yesterday and day before yesterday, we have heard this article of fast charging in the lithium batteries. Because of these advancements which are happening for last 7, 8, 10 years, this is possible, right? Because overnight you can't do anything like that. Now, that is one case which is very positive for lithium. But there are challenges, like for India, we don't have any critical raw material. You use manganese, you use nickel, cobalt, lithium. We don't have any of them. So sourcing is one issue. Second is your technology, because this is a technology-driven thing. And every now and then, technology upgradation is happening in energy density and other factors, form factors, fast charging and everything. It's all technology, basically. So we have some challenges. I am from Murugopa Group. We make electric trucks and we have our own battery assembly plant in India. We have an assembly plant of 2.2 gigawatt hour. It is a very large plant basically. And still we have to import the cells because cells are not being made in India. But the battery, ballast battery part like your BMS, your electricals, your thermal, your outer casing, all is made in India otherwise. So these are the challenges. Now coming to the new technology, which is your second part, sodium ion looks very promising, right? Because in sodium, the challenge of raw material is not there. Sodium is available on earth crust, sodium is available in seas, seawater and all that. So your raw material challenge is over there, okay? So that is very good technology. But there is a challenge of energy density again there because it is not that good compared to lithium. So you need around 20 to 30% extra space for the same battery what you design in lithium. So that is being now resolved and people are taking all that from lab scale to commercial scale and all that. So that is a very good technology which is coming up now, being used presently in ESS, the energy storage solution system in solar and other storage. EVs, still it is working out. Another good technology is your hydrogen. Hydrogen is rather, you can say, the best technology basically because the input and output both are green. So there is no carbon involved anywhere. So input is hydrogen and output is water. So it is the best technology. But problem is, there are three problems in it. One is your production. Production base is limited. Basically at one place or two places you can do. Transportation is the biggest headache here because it is very light gas and it is to be transported in a cryogenic form. And storage is a third big issue because wherever you transport, you have to store it again, and storage vessel is again cryogenic and all that. So presently, the cost factor is a prohibitive as of now. Close to $4 per kg is the present cost basically. So it is not giving that kind of benefit while running in EVs. So, but for long haul, it is the best technology presently for the ships, or you can for the long haul trailers or all that, even for the long haul trains. It is the best technology basically. So these are the new technologies which are coming. Solid state you touched upon. Solid state basically, see, it is a good technology, but cost wise it is very expensive because that kind of thing if you devise. There are 2-3 technical issues also because generally silica is used, so the bulging issue is also there. Cost wise it is around 25 to 30% expensive than the normal battery. So, but definitely it is a very condensed type of battery. It can do wonders when done properly. Okay, that is from my side. Tanvir,
Just wanted to add, I hope I'm audible.
Yeah, you are.
Though my only caveat or this thing is that there might be a lot of people in the industry who, in the audience who might want to invest in this space, or investors or funds, or generally looking at this space from the outside, because everyone talks about, okay, lithium is not here for the long term. There are other technologies on the horizon. I should tell you where lithium is today. It has taken it decades. Decades of research, decades of work has happened for it to reach this level. There is no technology right now on the horizon which can take that away from the current lithium technology. It's not like in the next 5 years also. It's not like in the next 10 years also. There's a lot of work happening. there will be technologies, different technologies being used in very niche use cases, but this lithium as a core material and in the current form as NMC or LFP as we see is not going anywhere, at least for the next decade or so. It's going to take a lot more effort and lot more supply chain and lot more work before it can reach the same stage.
So Tanvir, great point.
I will also just add
Yeah.
1 second. Just let me complete this thing.
Sure.
So initially, I started my talk with this only, that for last 10 to 12 years, lithium is doing very good, and it is a established technology. So what Tanvirji is saying also is echoing the same thing, that it is very good technology. Second thing I want to link here about the lead acid battery. So no battery is going out of market. Basically, see, the share will change. Lead acid battery you see is running in India for last 60, 70 years, is still there. And maybe the CAGR is not that good. Earlier it was 22, 23%. Now it may have come down to 4%. But still the lead acid technology is there, and it is still doing much more volumes than what lithium is doing. But any new technology which is coming will take some shape, will take some time to establish. And new technologies will have very small share, like we discussed about the new technologies of sodium or maybe hydrogen. So at some countries they are doing very good, like hydrogen is doing very good in some countries, but still in India it is not there. Because India, see, we are lagging basically in electric vehicle domain. We started just 5-7 years back very seriously. Before that we were not there. Reva example everybody knows, it came 20 years back and there was no ticker at that time. So we have to see the things, and I fully agree with Tanvirji what he is saying. Lithium market is there, will remain there. Only the shares will change. The percentage may go slightly here and there depending on the use case. Thank you.
And that brings us to another very interesting point. And since Tanvir, you made the point that lithium in its current maturity is decades ahead of any other technology which are nascent. So Tanvir, give us a bird's eye, and if you can, some amount of details on how are we looking at being able to reuse or do a second use once degradation sets in these kinds of batteries, and is that the answer more rather than looking at new technologies of being able to reuse them or something like that? Yeah, where are we there?
No, like before I share that, I think it's important for me also to share what gives me the right to speak on this question. Right. So I've been in the clean tech and e-mobility space for about a decade and a half now, having built a couple of startups already. My immediate earlier startup is called Moving, and it's today India's 4th largest battery swapping, battery as a service company, and spread across almost 30 cities today. And we've managed tens of thousands of batteries and assets across these areas, and that's something which has given me some insight. And in the current venture that we are building, there are a lot of problems in the industry which we are trying to solve, and while doing a research, because it's early for us, this is one of the key areas which came to us as a problem as well, where people talk of circular economy. It's today an overused and abused word. But I must tell you that there are a lot of recyclers in India which have raised money, but they're not able to run their factories because India is a very different animal, right? Before anything comes to recycling, before any circular economy talk happens, there is second life, third life, fourth life, possibly fifth life. In India, you will find a customer for everything. And India is the most unorganized, organized market which is there. You will have the local kabadi wala coming to you and taking that battery from you, and tomorrow you will see that kabadi wala, and I've seen this, that the guy who came to pick batteries from us which were dead, junk, 2 years back, today that same guy has been able to refurbish those batteries and sell those batteries under a brand name. Right, so that is what India is. There are people in villages or in, let's say, lesser areas where you have unorganized factories with untrained labor, but they are actually breaking open these batteries. They are sorting these batteries, cells. They are making new batteries. Forget recycling. Recyclers ko to maal hi nahi mil raha. They still have to import from Japan, Korea, Europe. They are not able to get any stuff from India because India mein वैसे ही बहुत काम हो रहा है. So this is just one of the things. But coming back to my point, answering what you were saying, we are talking of batteries, we are talking of electric vehicles, whether it's two-wheelers, three-wheelers, or four-wheelers, anything. Everything which is degrading will have a second life, will have a third life before we can think of recycling. One of the key things which is happening in the industry is that you don't understand what is the remaining useful life, which we call in our terminology as RUL. What is the remaining useful life of this asset, right? If you are from the industry, you would know that there is significant amount of data available to us, and we'll touch upon it. But that data is not being used the way it should be used, right? It's basically very superficial use. We put an IoT, we calculate voltage, current, temperature, but we don't really understand कि यार ये asset में हो क्या रहा है. Until and unless we do that, we will be selling these batteries for scrap, which is not something which India as a country we can afford. But the NMC batteries today or LFP batteries today, if we can make some changes in design at the beginning, there is a significant opportunity to use them in second life and third life. We can actually recover almost 50% of the cells and make new batteries for mobility. Forget energy storage. Energy storage comes as third life for it, right? But no one is thinking that way because हमें सबसे सस्ता product बनाना है. As a result, we have no other option कि वो कबाड़ में ही जाएंगे. There will be untrained manpower which is working on it, which is a big opportunity loss. So if there are people out in the audience who want to look at this space, I will urge you, this is a huge opportunity. Look at the batteries, work with the OEMs upfront, small design changes, right? Something as small as not doing laser welding and doing something else, which will increase the price, but that can actually give you 50% of the battery and cells back to again resell in the market for a mobility use case. That's the opportunity which is there. And when we started moving and we worked with these batteries, we always thought कि यार सीधा energy storage में जाएगी, but we found out that a lot of things are happening with these batteries where we can still use them in certain use cases where the range requirements are not very high, and we can still put them back into the market. And post that, they go for energy storage, right? And especially when it comes to LFP and NMC, LFP is where the majority of India is gravitating towards. LFP में वैसे recycling में कुछ नहीं मिलता आज. You will have to pay to recycle an LFP battery in future rather than get something out of it because the cost of extracting lithium is so high, it's useless. So the good thing is LFP batteries can easily be refurbished. They need effort and changes in design up front at the first OEM. If we are able to make that effort, we will not have to rely so much on these lithium imports, and we can actually increase our own self-reliance of batteries and the materials.
Yeah.
Can I add a point to
Yeah, sure.
Tanveer? Very interesting. So Tanveer heard loud and clear. And as an OEM, we believe strongly in repair before recycle because India is a very value-conscious market. You can actually see the example why something like a Maruti sells in the number it sells across the country because it's very easy to find spare parts, servicing, maintenance. The after-sales experience of that whole brand is one of the key factors why consumers select that. So just to give you a point that Wave Mobility, we actually have an IP with battery where it is possible to do cell level repair, where we can actually disassemble the whole pack. Even after doing laser welding, it is designed in such a way that it is possible to disassemble parts of it and do a cell level repair. So we understand that Indian customer is not one who would buy a 20 lakh rupee asset and say, oh, after 7 years of use, I will write off 10 lakh of its value and go for a new battery. That's not going to happen. So it's not just true for battery, it's true for the complete powertrain components because that is almost 65% of the cost of the vehicle. All of these products will eventually have to be repairable for a very large scale acceptance in the Indian market.
So, Nilesh, yeah, that is a good point, but we'll now shift our view a little on the charging infrastructure. So while battery and all that, yeah, that's great, but there's a lot to be done on the charging infrastructure, and this is where I'll also bring the concept of AI. Today, I did hear a couple of panelists, and I think the audience here has heard a number of them. A lot of them were talking about charging infrastructure wherein they're not able to cope up with the demand to supply at peak and all of that. So give us an idea of how the smarter grids are going to be. If you can also help us know when we could also be seeing vehicle to grid kind of a smart network in India. And the final one is, how do you see AI actually help on this, wherein they're able to,
I'm really enjoying being on this panel because the questions are coming from all directions, not the regular
no,
boring.
it's going to come from that also.
Yeah, no, no, I mean from very different tangents, not the regular questions that. So I'm very happy to be part of this panel. So AI is definitely. I'm starting with AI because it has the maximum impact going forward within the vehicle, between the vehicle and the grid, and in terms of as an OEM during the lifetime maintenance of the vehicle. So within the vehicle, it is completely changing the experience of the customer. We are seeing that customer wants to talk to the vehicle in a very natural way. So that integration is already happening through multiple modes. Second is as you talk about the grid. I think India is again right now we don't even have multiple operators on a single grid. And even that concept is still not yet there. So I think once that comes, your opportunity pricing, when there is an opportunity to make financial benefit, I think all those things will also evolve. And I think that will be the time when vehicle to grid will also come. V2L will come very fast because that is kind of an independent thing. So definitely all the vehicles that you'll see in the future will be able to take some local loads. Second point of the V2G is you need a significantly big battery, which in a market like India won't happen. So what I see is in European countries where the average battery size is 70 kilowatt hour, giving something back to the grid makes sense. When you yourself have only 35 kilowatt hour and you don't know whether there will be electricity tomorrow morning to go to office, you don't want to give it. You will keep it reserved for your own use. So I don't think V2G is making sense. But definitely solar assisted charging, because now solar has such a big push, that is happening, not the reverse way. So yeah, I think these are the points. And one point when we are talking about beyond EVs is we are all still talking about battery electric vehicle. I just want to say a small point is we have to talk about electric vehicles. Battery is just one of the ways we are storing the energy today. It will be different 5 years down the line. It will be different 15 years down the line and 25 years down the line. What has fundamentally changed is that an internal combustion engine has been replaced by a motor which is fundamentally 3 times more efficient. I think this is the change, not the battery. Battery is today, lithium ion is the most proponent technology, but that is going to change in future with multiple options. So we have to see this transition not just for today, but for like the decades to come.
And great point. And that's where Farhan, I'd need your expertise because I guess Nilesh is trying to touch upon that. Is that while we're talking about battery, we're talking about AI, we're talking about being able to, even repair a degraded battery. But Farhan, you with such a deep experience of two-wheelers and especially from a swapping perspective, let's kind of, if we shift our gauge a little bit to, and I could see that on one of the ads of Treel where they were showing that the guy can see the tire pressure and all. But where do you see, Farhan, AI in its final maturity with an Indian customer mentality? Where do you see what all could AI do for, let's say, an end customer could be a rider for a company on a B2B or a B2C who's bought a scooter, but what does he want to see on the app, and how do you see that entire fundamental change coming?
Good evening. So let me introduce myself first. My name is Farhan. I work for Bounce. I started. So before Bounce, I started as a co-founder 22 Motors, which was acquired by Bounce. So into EV industry almost 9 years now, and before that also I was in two-wheeler industry majority. So this is the background. what you were talking about, that AI effects in EV two-wheeler and how the EV infrastructure or battery swapping things are going to work. So I think AI is going to play a very big role the way things are moving. If I just go back that when we started designing our vehicle, we put up a VCU that's called Vehicle Control Unit. In that system itself, that we try to manage in a way that each and every command passes through that, and you can capture that. So you can do your preventive maintenance, you can work out and understand at any particular time that what is your vehicle life, what has been done in which part, like that. And now seeing that the gig worker coming to picture, where we are doing a lot of deliveries and grocery deliveries kind of thing, or food delivery kind of thing. Now swapping comes into picture, or the charging network is going to come in a picture. For the gig worker, what is important is that his vehicle is to be on. He can't afford to be hold up for some time. He needs that running. So swapping station are quite popular, and AI is playing as more and more vehicle come into picture. I think more algorithm will come in that, and AI can predict much better than what it is now. Keeping in mind that now what are the frequency or how many kilometers after that each station is available, the company can decide and change the number of battery at particular station based on the demand way, that at particular time in one area there might be more demand, you need more batteries to be deployed over there. In some of the area and some certain time where the battery demand is down, you can remove from that and deploy wherever this is more required. So I think it is going to very interesting time in future when AI will play a very important role. So this is what I can say. Just wanted to say what the battery, what is the second life, third life. What I feel is, I think what Nilesh says, that leave the battery aside, it's a IC versus the motor thing. I think that vehicle become more efficient, and it's not only battery. I think even the vehicle can be refurbished in a very different way, the way IC is not being able to do it, because a lot of wear and tear is happening in the engine. You can't do anything, which is not the case of the EV.
Yeah.
Great. I thank Sunil, Tanveer.
No, just adding on the AI part, I think the biggest question is, again, AI is also highly overused nowadays. But one of the key things where because we've done battery swapping, there's a lot of work happening when you're looking at with the OEMs or so on and so forth. But the simplest thing where AI has improved, because we were already doing a lot of machine learning and big data work, right? This EVs are connected vehicle, they throw a lot of data, right? It's important. If earlier what we were doing is we were any which ways reading patterns to predict exactly what Farhan said, to predict where we should put a swap station, where we should put a charging station. Can we give an intervention to the customer to tweak his behavior after reading his data key, so that they have to charge minimally, or can we divert the customer to a different charging station today rather than the one which he goes to regularly, because at that particular time of day that charging station is having a lot of load. This is more big data and machine learning, which is what has changed with these LLMs coming and these agentic AIs coming. Two key differences. And what we've seen, most of the adoption and most of the work, whether it comes to swapping or whether it comes to EVs with gig workers and e-rickshaw drivers, right? They are not used to using applications the way we see it, right? That's where agentic AI has changed a lot of things, right? Still the same work is happening at the back end, big data, machine learning, all those things are happening, but agentic AIs have changed the way we interact with our consumers. And I think that's across industries, not only EVs. And when it comes to looking at how LLMs are transforming, they're basically, if you know how to use them, they can actually help you design a better vehicle, because there's significant amount of data available. They can actually help you reduce the load on the charging infra, because there's again a significant amount of behavioral data which is available, and eventually it can help you do a lot more things. So AI is going to transform. The problem is even the foundational work in electric vehicle where AI can be used, that itself is not happening. Forget anything else. So I think we need to start much lower
True.
before we can do it.
Agreed, Tanveer. But we can look at a situation, Tanveer, where there's a gig worker who's rushing on a route to get his deliveries done, and the AI actually tells him to do the right thing or be able to take the right turn and something like that. So, yeah, that's always on the cards with an LLM. But, okay, now something really interesting and different, because we don't want to, I mean, you guys already have got a PhD, or you'll get a PhD in battery and all of that if we keep talking on that for a while. Abhinav here actually is going to help us understand, because while in Blue Wheels and on a lot of other projects when I was working for clients, one thing which is an expectation from the Indian sustainability industry and globally as well is carbon credits. So how are carbon credits got? What are Indian policies around it? What Abhinav we are able to do? Abhinav comes from Emergent, and he is at the cutting edge of all the decarbonization projects in the country. So Abhinav, help us understand, where are we in India from a carbon credit accreditation or a carbon credit enumeration or being able to get any kind of benefit from them? Where are we? Which direction are the Indian policies pointing to? And what are we going to see there?
Yeah, thank you. So I want to start with, are carbon credits real? Yes, it is. Can they be accessed? Yes. Can they be monetized? Yes. Right. If you are a charge point operator, charging infrastructure developer, manufacturer, right, fleet operator, it can be accessed. Right. There are standards, voluntary standards out there who help us in issuing carbon credits, and we can monetize them to get an extra piece of revenue, which will help in viability of most of the projects, which is in very nascent stage, right? In terms of what India is doing, so there are policies coming up. For example, carbon credit trading scheme, right? So the policy is out there, and hopefully it will start by 2026, mid of 2026, right? And they have mentioned that one of the target sectors is transportation, right? Now the problem, where is the problem? Why people are not able to access this carbon credits? Where is the problem? So one is obviously the energy that is coming to these vehicles are from coal, right? So the benefits that, we are reducing the tailpipe emissions by avoiding the diesel or petrol, right? The equivalent amount is getting emitted by burning the coal, from where we are getting the electricity. So that is the biggest challenge why these carbon projects are not viable for many players, right? One is obviously scale is not there, right? And second is they are not able to generate that much of carbon credit because of this coal-fired thermal energy. So it is very important to understand that if we are developing a charging infrastructure, it has to be powered with renewable energy. Then these carbon credits will make a lot of sense for getting the finance which industry needs.
So I had a couple of.
I know, Tanveer, but just before Tanveer, you give your.
Actually, I had a question this time.
But just a second, Tanveer. One thing that I wanted to point out, and Nilesh, and to both you and Nilesh, is that this also brings us to a major point of renewable in case of charging infrastructure. That's one. And secondly, so Abhinav and I have been discussing this a lot, just for the audience sake. So there is a complete bifurcation of how much of a carbonization happens from the production of electricity to the tailpipe emission prevention and all of that. We'll get to that also. But then we'll go ahead, please.
No, so carbon credits as a mechanism has been there for long. People have used it in solar, people have used it in wind. In India itself, it's been more than 20 years. But what we see today is that Indian carbon credits, whether it's solar, whether it's EVs, they have fallen in prices significantly compared to, let's say, carbon credits from Sri Lanka or carbon credits from similar other locations, which is making the whole cost of registering for a program, and because you have to monitor, I'm talking electric vehicles, for example, you have to monitor them. That means every vehicle needs to have codified IoTs, and there needs to be some stricter rules to do that. So the whole effort and the cost does not justify the amount of money that you'll make. Is that true? Because that's what we see from.
So that's a generic question about the market, right?
Yeah, because the prices are significantly low and the offtake is not that high today. Like, there are significant carbon credits generated in India which are not sold for months right now, or they can be sold at a lower price. If you can give some idea there.
So, the problem is, one, the carbon industry also, the carbon credit market is a nascent stage, right? It's not evolved, right? Second is, the Article 6 is coming, the mechanism that is, developed by UNFCCC, where countries can exchange credits by investing funds and they have the right to claim the carbon credits. That mechanism is coming in place slowly, right? And third thing is, like the question he said, credits from Sri Lanka is why the value is higher. So most of the time what happens is it depends on the co-benefits also. Like we are just targeting SDG 13, which is the environment, but there are other SDGs also, like life on land, for example, biodiversity. All these factors plays a role. So, whosoever company, ultimately a corporate is buying the credits to neutralize, but they are saying that, if we have something extra benefits that is given, maybe given to the community, maybe it is helping the biodiversity, so they will pay extra.
Okay, so carbon credits you're saying has different categories to them?
No, carbon credits are carbon credits. That's 1 ton of CO2.
Yes.
But the extra benefits that is attached to the project, that
Understood.
adds value to the carbon credit value.
Understood, understood.
Did I answer your question?
No, so partially, but my main question is it true that because India is only focusing on SDG 13 majorly, and because India may be same issues, right? Sri Lanka, if we have other SDGs, India also has different cities, different projects which are contributing to other SDGs. What you are saying is a certain project registered in India can have a higher value of a carbon credit, whereas a certain project will have a lower value, or it's standardized?
No, yes,
It's
definitely.
in
No,
India
it's
itself.
everywhere. It is not standardized. Some kind of project, probably a community projects or a nature-based project, for example, you are doing plantation, right? So that will have a higher value. That also depends on the benefits is tangible. So there are type of credits which is, one is avoidance. So in electric vehicles we are avoiding the emissions, right? One is removing from the atmosphere, like what plants are doing. So that is more tangible. You can touch it, feel it, that this much carbon is stored in this tree. So that has more value because it is transparent. Transparency is there. Transparency has value.
And why does it take so long to qualify a project for a carbon credit? Because it's taking months and months today.
I mean,
And what's the usual timeline and how much?
see, I can't comment on that because that's their
Let's-
part. Maybe they don't have the capacity
Okay,
or the resources to.
Tanvir, I'd say, okay, Abhinav, but yes, he has a point here. I was in one of the organizations trying to get that done, and the audits and all of that and the entire procedure, it has been made, or I don't know, it is pretty elongated.
I'll just try to summarize a little bit that I think there are 3 points in this small discussion. One is scale. Unless you have scale, it is not viable today to go for that kind of compliance, because as an OEM, we also tried to register for it and realized that the cost of operations was higher unless you have a certain scale. Second is, by the definition of, trading carbon credit, it should be a commodity, which it is not. A commodity should have a very consistent pricing across markets.
Very objective.
Yeah, it should be a very efficient market, which is not there. And third is supply and demand. So India doesn't have sufficient demand because there aren't regulatory requirements from the government to our industries to offset their carbon footprint, which is there in the West. And hence the demand is significantly higher in the West and very low. So I'm just trying to summarize the.
So next question to Sunil ji, and then we'll take on the Q&A. Actually, Sunil ji and Farhan, both of you. Renewable, the role of renewable in our charging infrastructure. So So Sunilji, when you're looking at the Montra launch and the trucks coming out and longer range trucks now coming in into the picture, so do you see certain geographies of the country in India that are now very focused on creating charging stations or at least piloting on some charging station which are which have this kind of renewable source?
Yeah, we started this project around 3 years back where we make heavy duty trucks of 55 ton. We were not able to sell because there were no chargers available at that time of that capacity on the highways. So whatever we have sold, we have sold few hundred numbers, but we have sold in heavy duty industry like cement plants, steel plants and aluminum plants and all that, where it is a closed loop function because chargers were not available outside. So basically we'll put our charger in the plant and electricity is available in these heavy duty plants. So they will do some 200 to 400 kilometers per day within the plant or to their warehouses and back and something like that. So charger, and in our case the battery capacity is 258 kilowatt hour. So it is a very high voltage this thing system, 614 volt is the capacity voltage there in the system basically. So we need some very, nowadays we are hearing of this megawatt chargers. So it has come now, but we launched our truck around 3 years back. So that time that kind of infra was not available. So now that kind of infra is available. Second important point is that your charging rate, because when we say that we can do fast charging, so different companies are using different kind of cells and different kind of technology and different type of C rates and different kind of cooling. So charging also depend on that. So there is a interface basically, the CAN2 protocol is there. It will communicate between the battery and the charger that how much current or at what rate it can go and all that. So that kind of protocol is built. So these problems are were there. Now they are being solved. PME drive, we have a budget of 2,000 crore for the infra chargers. So I am very hopeful that these chargers will come. Some pilots have already been done on some highways like Delhi, Jaipur and other places in south also in Chennai and all that places. So some identification has been done from the ports also, that from ports if we can have some charger placed in a range of 500 kilometer radius, then some trucks can ply in that thing. So all that has been done. Now implementation part is to be seen. The second part was about the renewable. So I'm talking in short because of less of time. So second part is of renewable. So we have a target of 500 gigawatt hour. The government has set a target of 500 gigawatt hour of renewable by 2030. And we have already achieved 210 gigawatt hour out of that. So in grid, when we were talking of the carbon credit also, so in grid we have a mix of 210 gigawatt hour, which is available in the grid. And our target of 500 looks quite achievable. So it is very important because there are two things. One is your emission from tank to wheel when we talk of our battery technology in the electric vehicle. So tank to wheel, it is negligible because it is all electric. But when we talk of well to wheel, then it's much more because then you have coal and everything, all gases involved and all that natural gases there. So much things are involved while generation, that thing. So renewable will play an important part. I think we are on the right part, what I see. If 500 gigawatt hour is achieved, then it is a very good achievement.
Yeah, that is really pretty much there. And you've already achieved 210 gigawatt hour. That's amazing. Farhan, the question to you as well. You are mostly, you've seen in your experience with Bounce and the two-wheelers, you have looked at all the battery swapping and all of those kinds of technologies. But are you seeing anywhere in the horizon that a lot of those stations and those places, at least for the peripheral or ancillary electrical utilization, they are using some renewable source like a solar or, I mean, the solar would be most useful, right, for any swap station or no? I mean, even for just their own lighting or something like that, are you able to see that already come in or no, that's not?
No. If you look at the total in EV from electricity generation to utilization, the vehicle dispatch in the logistics where you are using the EV while going on the truck which runs by gasoline, correct? So you have to see in total ecosystem in that. And in manufacturing, the grid, one part is that generation of the electricity is one part, that's government level is doing that. But I think as a EV industry, we can also do a lot of other activity, like in our manufacturing system itself, how we can utilize the solar energy, the
Yeah.
rooftop energy kind of thing.
Yeah.
How can we utilize the equipment which are non battery driven rather than gasoline fork rates and other things can. So it's utilization of energy, renewable energy in the complete ecosystem. I think it is going to give you the more carbon credit.
So
and all those
do you see currently, like Sunil ji said, that he is already, I mean, in Murugappa Group, in their Montra manufacture and the entire thing, they already have 210 gigawatts of renewable already achieved.
No, that's I think for the entire India.
entire country. I think he's talking about the country.
Ah, okay.
Yeah,
Oh,
yeah.
that's the additional. Acha. Okay. Farhan, do you see in the current way?
So I'm saying, I think the industry is working, not only EV, even the entire industry is working towards renewable, and a lot of activities being done for the utilization of rooftop solar or other activities. Thing is, what I see that in future you might have the multiple factories where you can avoid transportation from one place to another place. Like you can't send the vehicle in a small truck because of the logistic cost. So you might need some, area like in south, you might have one small plant in north, you can have in west, so that you can minimize this loss of, gasoline utilization. Though you are trying to, do this EV kind of thing where you are working on clean energy, again in transportation you are
In
using
procurement and all
gasoline
of
kind.
that side.
Yes,
Okay.
correct.
Tanveer?
Can I add?
Yeah.
So I think what you were asking twice is क्या charging station, swapping station पे solar लगा सकते हैं या नहीं? I think basic. So it's not viable.
Because Abhinav is telling me कि
It's not-
sir, you're losing all your carbon credits there because finally तो coal से आपका electricity आया and then you
नहीं, so-
put it into the electric.
It's not viable. The only place, so there are only two clear use cases where renewable, primarily solar, can be used to supply power to a charging station or a swapping station. One, if you have, like he said, megawatt level chargers, where you need megawatt level electricity to pump through the chargers, there is a government scheme which comes under open source for solar, where now they have actually come out with 1 megawatt. If you have minimum requirement of 1 megawatt, or actually, this scheme is about 1 megawatt. If you have minimum requirement 1 megawatt, you can actually ask for open access solar power, right? So that allows you to put up a large charging station infrastructure, access that power from somewhere in the state, and that can be pure solar. That's point number one. The other point is, if you are on highways, right, just putting up a solar does not make sense. There is a concept called long duration energy storage, LDES, right? So there you need LDES systems. Today it is not viable because we don't have that much utilization on these highways, but tomorrow, when the time comes, solar coupled with LDES is what will remove the need for gensets on the highways and give you constant power, and that will be 100% renewable, but it is dependent on utilization. So these are the two use cases.
Sure. Nilesh, finally, before I open the Q&A, what is the time frame you're looking at? Just what do you expect on the highways, given that we have amount of trucks that Montra and the Ashok Leylands and the Tatas are going to run?
No, definitely for commercial application, at least in the green corridors that have been declared by the government. I think by 2030 we'll see most of these green corridors fully covered with charging stations every 20 to 50 kilometers. I think that's very much doable. The grid is supporting that.
I'll just open the whole dais for any questions from the audience here, please. Mike.
Hi, good evening. We are someone who are dealing with failed batteries. So we do repair and refurbishment. I have a question. Do you think advanced diagnostic is required at the level of checking the cell quality, fundamental cells? Because the most common failure is string failure in the battery pack. And you find one cell, rogue cell, which is destroying the entire battery pack. So do you think this should be the area of focus?
No, it's obviously, if you can do that, or if any operator can do that, it makes for longer life of the battery, and you can actually give that information to someone like you and your life becomes easy. The problem is not a lot of people are doing that, or not a lot of people have the ability to understand data or share that data with you because that chain is broken. But if you're able to do it, your life will be much easier. So it should be done. It's not that difficult.
Just adding one thing. So it is answer is yes and no. If you do it, it's good, but you won't get that data. Even if there is a battery pack failure, the data gets lost. Rather, the newer thing is how can you characterize a cell anytime during its lifetime. So I give you an instrument that you can characterize your cell irrespective of whatever be the history. And that has evolved a lot in the past. So we are talking about at multiple frequencies, check the internal resistance and those kind of things, which were earlier only R&D equipment, are now coming in line in production. So those things can be used by you also to characterize your cell better and not depend on any history to be provided with the cell.
Yeah, I will also add one point here because you are talking of the cell basically. So see, first important thing is your sourcing. So I see a lot of people sourcing from second grade suppliers or third grade suppliers due to the cost factor. So definitely they will face problem. But if you go to tier 1 supplier who are the top 5 in the world or top 10 in the world, then they have very strict internal controls where no bad cell can come out. Second, in our factories, we have a sorting process where we have sorting machines which will check the IR and everything of the cell voltage and everything. And then they will club the cells of each grade, right? And then you can make the battery pack out of it. So sourcing is very important. Second important point is your charge rate. Generally what is happening in solar, generally people go for 0.5 C kind of cell because the sunlight is available only for 4 hours and discharge is very low. But in EVs, the discharge is very high. If you take a case of like a electric bike, the discharge can be 5 times higher. So you have to go for a 5C type of a cell basically. So cell selection is very important. Don't go for 1C type of cell, always go for 3C type of cell for better protection.
And I'd strongly recommend that you talk to them one-on-one. They are going to come down the dais. I think we have run out of time. Please take it up. But any final urgent questions? Yeah, please. Yeah.
This is for sir on carbon markets and Tanveer and Abhinav, Abhishek. Sorry, but the question is that how do we, and everybody actually, so how do we incentivize? So suppose I take a e-rickshaw ride after exiting Taj Vivanta. Now how do I incentivize that e-rickshaw ride? And because of my behavior of actually, taking that e-rickshaw or electric mobility, earn something which is related to the carbon credit. So is that possible? Can that be architected? Can that Paytm-like platform be made? Thank you.
See, this is a very small level at one e-rickshaw, right? It will not be viable for anyone to claim for one e-rickshaw and for one ride, probably 100 rides, right? How it happens is somebody is operating an e-rickshaw means he is responsible for reducing the emissions. Now they might be operated by somebody else, like a fleet operator. Then they get the ownership of the carbon credits. So until and unless it is at a scale, bigger scale, the viability of getting a carbon credit is very low. It's negligible.
Just adding on the e-rickshaw side, right? The IoT and the related costs to actually uniquely identify these carbon credits for that particular rickshaw today are much higher than the money that you will get from the carbon credit. So even if you are able to get a fleet together, you'll have to put an IoT everywhere, you'll have to pay for it, you'll have to uniquely identify, do that registration process. By the time it becomes viable that you can give something back, that is too long today. That's why I'm saying this is a problem with the rate of carbon credits that we are able to generate in India for these use cases in mobility, right? It used to make a lot of sense earlier when there were few projects. Now the projects have increased all over the world and people prefer certain SDGs over others. अभी वो viability नहीं है. आप जब तक register करवाओगे, IoTs लगाओगे, IoTs का monthly खर्चा दोगे, server का खर्चा दोगे, सब कुछ दोगे, उसके बीच में उसकी viability खत्म होगी. पहले आप अपने पैसे पूरे करोगे before you can give it to someone.
I'd still say that it could work. I think a major aspect which Abhinav told us was, one is policies in India are getting coined around it within a couple of years. plus I think a couple of questions around why Indian carbon credits are lower or higher. It tells us something about the objectiveness and the standardization. If these two things can be achieved over a universal global code, then there could be a way to make the end customer in the B2C actually pull the credits towards him, and that could that kind of an app or an AI could actually become the spark which gets the entire supply line of carbon credits streamlined. But we'll have to see.
I just want to add one thing. So in the last panel, I think Mr. Gupta said that they are building something with the village panchayats, right, remote village, solar powered charging stations, right? So that can fetch a higher value because it is providing a community benefit to villagers. So that is the use case.
Well, I believe that this session was quite escalating, and I believe every person who has attended this session will take away few pointers, insights, and knowledge from the respective people that are present on the dais. With this, thank you to all the gentlemen present on the dais. Everybody, please give the entire panel a huge round of applause. Everyone, please. Thank you.